Hello my fellow scientists. In this video, I want us to consider horizontal projection. We are considering a body which is initially projected with a horizontal velocity u meters per second. So as this body moves in the air, it is going to trace a curve. Because of the air resistance, this body will not move forever in the air, but it is going to fall due to the resistance. So as the body moves horizontally, it also experiences the vertical projection, the vertical movement due to gravity, which will be exerted on the air. And now from the standard equation of uniform linear motion, whereby we know S is given by ut plus half gt squared. Here S is the displacement, u is the initial velocity, t is the second, and g is the acceleration due to gravity. Now, along the horizontal, the acceleration due to gravity is 0. So g is equal to 0 meters per square second. So substituting 0 in this equation, where you have g, you substitute with 0, we are going to find that S is equal to ut plus half 0 multiplied by t squared. So S is equal to ut. So horizontally, S is represented by R. R stands for the range of the projectile. R is given by ut here in this diagram. So when the body is projected horizontally with initial velocity u, after some time t, that body will recover a distance r from the point of projection. It will have covered distance r. R is referred to as the range. So here r is the range of the projectile. The distance, the horizontal distance which the body will have covered from the point of projection, and it is given by ut, where u is the horizontal velocity and the t, it is the time which the body take to cover this particular range. Now, when we consider the horizontal component of the body which is projected horizontally, now from this equation of standard linear uniform motion, S is equal to ut plus half gt squared. Now, along the vertical, the initial velocity of this body is 0. So u is equal to 0 meters per second along the vertical component. So we substitute u with 0 here to get S is equal to 0 multiplied by t plus half gt squared. When you simplify, S will be given by 0 times t is 0 plus half gt squared. So along the vertical, the height is given by, will be given by half gt squared, as shown in this diagram here. So the height of the body which is projected horizontally with the initial velocity u is given by half gt squared. So watch out for the numerical example of a body which is projected horizontally with initial velocity u. So the next, I will give a numerical case. Here we are not taking consideration of the angle at which this body is projected and the angle at which this body land here. We are not taking consideration into this because of the level. So this is the elementary part of our discussion. So kindly remember to like and to subscribe to this channel so that you do not miss a single video which I upload. This is mostly physics for beginners at the level of grade 10 to 12. And also it is very, very important for those who are pursuing physics in higher level, since this one builds the foundation of what they are going to learn.